All right, everyone. Welcome to this next set of notes. So make sure you have your paper and pencil ready to copy. And here we go. So the first thing that we do, as always, is we are going to identify the name of our notes. And these notes are called similar right triangles, right? So we're going to cover similar right triangles. Last time we did similar triangles, but this time specifically we're going to cover similar right triangles, right? Meaning that triangles that have a 90-degree angle, correct? So, first thing that we notice here is our definition, which says if the lengths of the hypotenuse, which is the longest side of a triangle, and a leg of a right triangle, one of the two other sides of the triangle, are proportional to the corresponding parts of another right triangle, then the triangles are similar. That means fancy words for if the parts match, if they are proportional, like they were in the similar triangles lesson, then the triangles are similar. So the way that these triangles are presented is like this, right? So you got this big triangle here. But then within this big triangle, they draw a height, an altitude from the top straight down to the bottom and forms 90 degrees. That's called the altitude, the height. But when you do that, you actually create two more triangles right there. This red one, and then you also create a little blue one like this. So what ends up being is a large, a medium, and a small triangle, right? The large is the original big triangle, that is 90 degrees right here. And then when you draw the altitude down, you create a medium-sized triangle, which is 90 degrees right here like that. And you create a small triangle, which form 90 degrees right there. And this is what the three triangles look like, right? Big, medium, and small. Well, it's a pain writing out and separating the big triangle. So what we've done is we've come up with a shortcut on finding the missing parts of this triangle. So the first sort of shortcut that we've come up with is called the altitude or height rule, right? The altitude or the height rule. So we need three parts there. We need the part that goes from the left to the center here to the altitude of this triangle, which is what we call A. On this one, it can be any letter, right? But this one is A. And then from the right angle to the right side is what we call B. And then the altitude or the height is called H, right? So the way that this sort of relationship works is this is the special shortcut right here. So what you do is you create a proportion, which is a fraction equals a fraction, right? And check this out. So you take the heights. What we're going to do is we're going to take these heights here, this height, and we're going to do a height right there on the top left. And we're going to do a height on the bottom right. Got this backwards. A height on the bottom left and a height on the top right. And I bet you guys can take a guess of where this A and this B is going to go, right? Exactly. This A is going to go there, and this B is going to go down here. And that's what we're going to use, right? When we are missing the height, when the height is missing. So when we have X here, when this equals to X, and let's use this green here, when this is equals to X, we are going to use this altitude height rule, which is this one here. All right? We're going to use that altitude when the height is missing. All right? Second rule we're going to use, and this is called the leg rule. The leg rule. So this is when the leg is missing, right? When we're missing a leg on the triangle. And the legs are the two parts on the side, because so what happens is that this is the big triangle right here, right? And this right here, kiddos, is the longest side, which happens to be opposite the 90-degree angle, and this is what we call the hypotenuse, which we will talk about in the near future, actually. Hypotenuse is the longest side, so that means that the two shorter sides are called legs. This is leg 1 and this is leg 2. So, let me show you. So there are two rules that we must remember with these legs. So there's leg left, leg 1, and leg right, leg 2. So again, we're going to come up with a proportion here, right? And this is if leg 1 is missing. What if leg 1 is missing? So we're going to say L1 top right and L2 bottom left, right? Now, if you notice, which one of these two kiddos, A or B, is touching leg 1? This is leg 1 right here. Now, is A touching leg 1 or is B touching leg 1? Well, it's obvious, right? If this is leg 1, we know it's not B. B is all the way over here. So A is touching leg 1. So A is what goes here on the top left-hand side. Now, the bottom right is actually a little different. The bottom right is actually A and B together, which in this case is P all the way to Q. P all the way to Q. So let's call that P to Q, right? P to Q. And that is what we're going to use when we have a leg on the left that's missing, right? Or, so let us type in or, I bet you guys already know, since we worked on leg 1 first. My God, look what I did here. You guys didn't even tell me. This should say L1. Huge mistake there, guys. But I corrected it. Mistakes happen. L1 on both top right and bottom left. We're only dealing with L1, with leg 1. Now we're going to deal with leg 2. So let us deal with leg 2. So again, I'm going to create a proportion equals, and just like on leg 1, I'm going to say L2 top right, L2 bottom left. Now again, L2 is over here, and it's obvious that it's not A that's touching L2, it's B. B is touching L2. So B is what's going to go up here. And then just like the first one, we're going to get the whole thing, A plus B, this whole thing right here, which is PQ. So that is what we're going to put down here is PQ, just like that. So those are the two that we're going to use, these two formulas, depending on what's missing. If leg 1 is missing on the left side, or if leg 2 is missing on the right side, right? And that is what we call the leg rule. And first, we talked about the altitude rule. So these are the three things we're going to use to do our assignment. Okay? So let's take a look at how we're going to use these. So the instructions on here say, find the missing side indicated. Okay? Leave your answer in simplest radical form. We're going to talk about that. I'm going to show you. Okay? So let's take a look at our first example here. So let us see here. So what is missing here, kiddos? What is missing here? Well, we know X is missing. Look, it is the left side of this triangle. Well, wait a minute. Left side, so that's L1. So I'm going to use this right here, L1, right? So I need my A, so I need an L1. So let us write down what we need. We need an L1. Let's see what we need. We need an A. And we need a PQ. Okay? So we need a PQ. So let us see what L1 is. What L1 is here over here on the left side. So L1 here is X. Okay, so L1 is X. What is A, kiddos? A, okay, A is right here on the bottom left. So what is on the bottom left here? 64. All right, 64, look at that. And let's go back here again and let's look at, let's see, this is PQ, so the whole thing, P to Q, okay? Look at this. From left all the way to right is 289. How about that? 289. And we're going to use our formula right here. Right? So let me zoom out a little bit here, like that, and let me say A is equal to L1 is equal to L1 over PQ. So now all I have to do, kiddos, is plug in what we have. So let's plug in what we have. So let's see. A is equal to 64. So it's going to be 64 over L1 is X equals another L1 is another X, and PQ is 289. Look at that. And now we are going to butterfly multiply, right? Let's butterfly multiply or cross multiply, like some people call it. X times X and 289 times 64, right? All right, so we're going to use our calculator, everybody, to multiply 289 times 64. Well, the easy part is X times X, right? So X times X is equal to X to the power of 2. Because let us remember that this is X to the power of 1, X to the power of 1. 1 plus 1 is 2. Now, let us do 289 times 64, right? So we're going to go over here and we're going to say 289 times 64 gives us 18,496. Okay, 18,496. 18,496. Perfect, right? But not done yet, kiddos, because I want to solve for X. This is not X, this is X squared. So I want to get rid of this thing right here, right? This is a square. The opposite of squaring, remember? Opposite of squaring is square root on the left side. So we're going to find the square root, right? Or radical. We're going to find the radical, the square root. So I'm left with X here because the 2 is gone. So I'm going to find the square root of 18496. So I'm going to go back to my calculator, and I'm going to look for the square root button, which is right here, and I'm going to type in 18496. And look at that, 136. So I go back over here and I say 136, and boom, kiddos, look at that. There's my X. I have found my X. That's the first example. There you go, right? One step at a time. We found L1, we found A, we found PQ. We put it into the proportion. We butterfly multiply, cross multiply, bird, right? Maybe this looks like a bird. I don't know. Should I change it to bird multiply? I don't know, right? We found the square root, right? We cross out square and then we square root, and we got X is equal to 136. Perfect, everybody. Perfect, perfect, perfect. Okay, let's do one more example here. So this, I noticed, look, X, the height is missing, the altitude. So I'm going to come up here. I'm not going to use the leg rule. I'm going to use the altitude rule, right? The altitude rule. Okay, so I need A, I need B, and I need H. A, B, and H. Okay, so let us find A, B, and H, right? So let us find A, let us find B, and let us find H. So let's see. Well, H is the altitude, the height, right? And the altitude here, the height is X. So H is X. B here is on the bottom left of this big triangle, and the bottom left is 25, okay? So this is 25A. And then B is over on the right side, and that's 144. All right, 144, just like that. So our formula here says, right, A over H, right? So our formula says A over H. That's not a H, that's an N. H is equal to H over B. H over B. Look at that. So now all I have to do is plug in the information that I have. So A is 25, so I'm going to say 25 over H, H is X, equals H, which is another X, and B is 144. Just like that. So, just like the previous problem, right? We are going to bird multiply, butterfly multiply, I don't know, or cross multiply, right? So the easy one here is X times X is X to the power of 2, right? Because remember, invisible 1 here and invisible 1 here, 1 plus 1 is 2, so I get X squared, right? And then I have 25 times 144, 25 times 144, so I'm going to go over here and I'm going to say 25 times 144 gives us 3,600. So I'm going to go back over here and I'm going to say 3,600. And then again, the opposite of a square is a square root, so I'm going to cross out this square, the power of 2, and I'm going to square root. So I get X by itself, which is what I wanted, and the square root of 3,600, so the square root button is right here, of 3,600 gives me 60. Look at that. That gives me 60, and that right there, kiddos, is my solution, right? I found my height. The height of this triangle is, of this triangle here, is 60. X, found my height. And on the first one, I found my leg 1, my L1, which was 136. And that right there, kiddos, are the kinds of examples you're going to see in the worksheet, the similar right triangles. So please make sure that you are good. Rewind if you have to. Took down really good notes. And again, I thank you for being here, and see you next time.